So welcome to our Exam 1 review video. My encouragement to you for each of these problems is to pause before I begin the solution and attempt this on your own. The whole goal of this review video is for you to assess your understanding of the material, so you need to be able to actually try it on your own and then based on my solution see if you got the question correct or not. If you missed the question, go back to our course notes and find similar problems and work problems from that section, and you can also reach out to me for help. Send me pictures of your work and I'll be happy to give feedback. So let's get started on this first problem. As we can see, we've got our piecewise function, and the way piecewise functions work is, remember, based on the domain listed off to the side, that's where you use each branch of the function. So when x is less than or equal to 4, the function acts like negative x plus 3. When it's between 4 and 7, not including the endpoints based on the inequality, it acts like x squared plus 5. And now because I've got this greater than or equal to, when we're 7 or greater, it acts like 9x. So based on the input value, I have a different branch of the function. So for f of 0, 0 is less than 4, so that means I'm acting like negative 0 plus 3, the first branch of the function, which is 3. For f of 4, now see, this is or equal to 4, so I still am equal to 4 here, so I plug in the negative 4 plus 3, and I get negative 1. Now at 6, I'm clearly in here. I'm inside the area between 4 and 7, so now I'm acting like this one, 6 squared plus 5. That's 36 plus 5, which is, I believe, 41. So now for the next one, we have at 7. Now at 7, notice this doesn't include 7, so we go to the next branch, which has a or equal to sign, so it includes 7, so it's 9 times 7. And then finally at 8, since we're greater than or equal to 7, that would be the last branch, so 9 times 8, which is 72. Okay, now we're about to start the next question. Remember, my guidance is to always pause, try it on your own, unpause to check the solution. And this is just a quick review video. More detailed solutions are included in our lecture notes that cover each of these topics. So here I see, based on the way it's written, I have g of f of 3. This is function composition. So I look at the input of 3, and it's being input to the function f. So I go to my x value of 3. Okay, here we go. And it says, look over what the f value is. Well, f of 3 is 1. So this becomes g of 1, because f of 3 gets replaced with the output value of 1. And now I go to the x value 1, and I say, okay, what's g of 1? Well, you look over at the graph, you see it's 1. Okay, so now the next one. Now in the next one, g is the inside function, and we're inputting the value 0. So I go to 0, and I say, what's the value of g at 0? Well, it's negative 1. So f of negative 1, because the whole g of 0 gets replaced with negative 1. And now I'm like, okay, negative 1, here's my x value, but I care about the function f, so we look over, and that's 4. Now here's just a hint. If the exam is going to be digitally displayed on your screen, you can't interact with it like I did here. You can't mark it up because it's on the screen, but you can use your off writing hand and point to the table and kind of hover over the screen so your mind stays focused and you don't accidentally get the wrong value when you look off. So just keep that in mind as a hint. And now the last one is not a composition of function, it's actually an inverse. So it's saying g inverse of 4. So remember, this is saying g of what input value gives you 4. So instead of starting at the x values and looking over, I've actually been given a g value. I'm going to look down the g column and see where is it equal to 4. Do we see it's equal to 4 at the last row, which corresponds to the x value of 5? So g inverse of 4 is 5. So we're at our next question, and again, remember, always the guidance is to pause, try on your own, and then unpause to check the solution. So I can see I've got a piecewise graph, and the way I know I have a piecewise graph is I've got a distinct behavior. It's a straight line to this point, and then all of a sudden it changes to be a non-straight line afterwards. If I'm trying to find the solution and it's a multiple choice, I think the best thing is to come up with the solution on your own, or at least close to the solution, and then check which one's right based on that. it can be difficult just looking at these to catch minor detail differences, which could make you lose the whole problem. So the first thing I'm going to focus on here is they all have to do with the value 0. And indeed, that's because that's where the function changes behavior. At 0, before 0, it was acting like a straight line when we were before 0. And then after 0, it was acting like this parabola shape. Now, if you glance, all of the answer choices have the same inequalities: less than, less, greater than or equal to, less than, greater than or equal to. So at this point, the inequality of the piecewise function is not going to help me determine it. I need to be looking at the functions themselves. And as I glance, I see I've got the straight line. That's going to be the easiest to write. Do we see it has a positive slope because it's increasing? And it also has a y-intercept at 1. Well, lines are of the form y equals mx plus b, where this m is the slope, b is the y-intercept. So I know it's y equals, okay, my slope is definitely a plus 1, and it's going to be some positive number. And while I could calculate this, since the whole point of this question is writing piecewise functions and it's multiple choice, I'm going to see if just keeping in mind a positive number slope plus 1 would be enough to kind of siphon down to the right answer. So looking here, this has a negative slope, negative slope. So automatically A and B are out because of negative slope, because our graph is increasing its positive slope. Now, the only difference between C and D, they both have 1 plus x, so that's our line, 1 plus x. The difference is this has a negative in front of the x squared, whereas this is a positive x squared. Well, parabolas look like this and like this, depending if the ax squared, it's upward facing if the constant in front is positive. It's downward facing if the constant in front is negative. So of the two of them, I believe our graph looks most like this portion, right? So that tells me we're looking at a negative number in front, which means D is not the answer because it's a positive. So the branch of our function should be negative x squared, and that's where C is our answer. So here we're asked for this function. Based on the tables and the value, is it 1-to-1 or not 1-to-1? As soon as we hear 1-to-1, we think in our mind horizontal line test. The idea of 1-to-1 is for every input, there is a unique output. So what I'm going to be looking for in short is for each unique x value, it needs to go to a unique y value. So I don't want any repeats of y values. So looking at this graph, I've got a y value of 3 that goes to 1. That's good. 3 goes to 5. No repeats so far. 4 goes to 7. But do you see 6 goes to 5? We've got 2 repeats. And in fact, if I graph these points, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, that's at 6, 6 is at 5. This function would not pass the horizontal line test because I've got 2 output values at 5. So because I've got the same for different x values, it's not 1-to-1. Now, next up, I'm asked, is this a function or not a function? The whole idea of being a function or not a function, that should think in your mind vertical line test, and basically saying every input has an output. You can't have an input going to 2 different outputs. So as I look here, 1 goes to 3, 3 goes to 2, good so far, 4 goes to 7, 8 goes to 7. Now, while these repeat, that is okay for a function. It's not okay for a one-to-one function, which is a more specific kind of function. But all this means is that this function, 4 goes to 7, 8 goes to 7, what would be a problem and make it not a function is if I had, for instance, x and y, and I had 1, 3, 5, and then 5, and I had like 0, 2, 6, and 8. This is a problem because 5 is said to go to 6 and 8. It can't make up its mind. It's going in two different places. This is not a function because you have the same x going to multiple y's. That's a problem. But different x's can go to the same y, and that's okay. So the original example is a function because I have x's going to specific y's, and I do not have the same x's going to different y's. That would be not a function. So here I've been given a graph and again asked about one-to-one or not one-to-one. Earlier we had the table version of this question, but if I ever have been given a graph, then I can very easily apply the horizontal line test visually. We still applied the horizontal line test by looking at the table values, but it is easier when the graph's in front of you because you can visualize it. So when you're doing this, you would basically look and say, if I could imagine drawing any horizontal line, will it cross through the graph more than once? And as you can see in this graph, it does not cross through more than once. It passes the horizontal line test, so it is one-to-one. Now here I'm asked to find the domain. For this problem, I'm going to solve it first, and then I'm going to look at the multiple choice answer problem so I don't make a small detail mistake just by trying to look and decipher them without working out the problem. We know for domain, you're asking yourself, where is a function have problems? Well, the square root has problems when the square root, what's under the square root, all of this can't be negative. It can be 0, it can be positive, it can't be negative. So that means I'm going to take everything under the square root, 2x plus 4, and I'm going to see when is it less than 0 because that's where I have a problem. So now I need to solve using algebra. So I'm going to say, okay, I got to get x by itself. We need to subtract 4 from both sides. 2x less than negative 4. Okay, I'm going to divide both sides by 2. And we get x is less than negative 2. So this is where we have a problem when x is less than negative 2. So that means we are okay in everywhere except there. So we're okay when we're equal to 2, because you have to be less than, but you could be equal to negative 2 or greater than negative 2, because we just can't be less than. So in this case, my answer would be B. Now, personally, I usually solve where do I have a problem, and then do you see how I kind of reversed it to get the solution? That's fine if you do that. If instead you just wanted to find out where you're okay, you could have, instead of setting this equal to less than 0, you could have said, let's see where 2x plus 4 is okay. We know it's okay if we're greater than or equal to 0. And then when you solve the solution, you get the answer directly. You don't kind of have to invert it. So do think about that. However you set up your inequality, are you finding where you want to be, in which case you've got your direct answer, or are you finding where you don't want to be, and in that case you have that second step where you have to invert it? I'll try to model the finding where you want to be in the next example so we can see that as well. So take a moment to look at this one. So I see a few things. I see that I've got a square roots, and I know square roots can't be negative. And I also have a fraction, and I know fractions have problems when the bottom is 0. Can't be 0. So in this case, when you've got two kind of issues with the domain, you solve them both and then kind of make a combined inequality. Now in this case, let's solve where it can be. We know the top can be anything that's 0 or positive. So x can be greater than or equal to 0 and will be okay for the top, because I just can't be negative. Now the bottom can't be 0, so it's okay for anything that's not 0. So we're looking and saying, let's figure out when the bottom is not equal to 0. We just don't want it to be 0. So I'm going to add 25 to both sides. And we get x squared cannot equal 25. Well, when would x squared equal 25? So x squared equals 25 at both 5 and negative 5. Keep in mind, whenever you've got something squared equal a number, both the square root of the number and the negative square root are the solution. So x cannot equal negative 5, and x cannot equal 5. So as we're thinking about this, sometimes I like to draw a number line. So for the top, we've got our 0, and it's saying we're okay here and everything past it. And we've got these exclusions. It says you can't be at negative 5 and you can't be at 5, but everywhere else is okay. Now, because of the top not being able to be negative, none of this part is part of this expression because of the square root at the top. So our lowest value we could be okay with is 0. So I could say I could equal 0, and I could go all the way up to 5, but because I can't equal 5, I've got to do an open parenthesis. And then I've got this next branch, so we do our union, and we pick back up at 5, not equaling it. And you see we're okay with everything else going out to infinity. So this would be my answer. And I look at the answer choices. Now notice C and D are very close. But the difference is here's a parenthesis, here's a closed bracket. This would be my answer because we can equal 0. So closed bracket is when you equal. Open bracket is when you're not equal. So watch out for those small details. So for this next question here, we are given the function f of x is the square root of x plus 5, and g of x is 2x cubed plus 1. Find, and now looking at this notation, we see the function g of x is inside the input of f of x. So we have a composition of functions. And we know when we have composition of functions, the order matters. What's the inner function? What is the outer function? So here, g of x is inside the parentheses. So it's our inner function. So that means everywhere there is an input in the outer function f of x, so we look at f of x, this is where inputs to f of x go. Everywhere there's an input in f of x, since it's our outer function, the entire function g of x will go there. So whenever we write f of g of x, well, what does f of x do? It says square root whatever the input is. So now my input is all g of x. So square root of 2x cubed plus 1. And then what does f of x do? It says then add 5 to it. So separately, because this is our whole input, we then add 5 outside of the square root. So looking at our answer choice, we see D correctly represents that. So here I have f of x is x plus 5 squared, and then g of x is just plain x plus 5. And they want us to evaluate the value g of f of 0. Again, we have a composition of functions. F is my inner function. So I input 0 into its x value. So what does f of x say? It says for every x value, you say that value plus 5 then squared. So this is g of, okay, now inputting 0 into here. 0 plus 5 all squared. Now I'm going to simplify this. That's equal to g of, okay, 0 plus 5 is 5. Then we got to square it, so that's going to be equal to g of 25. Now what does the function g do? It says take your x value and add 5 to it. So now I'm going to say 25 gets in place for the x, so that's equal to g of, or not g of, sorry. By plugging in the 25 to this, I'm evaluating the function g. 25 plus 5, and that's my answer, 30. So here it says identify the equation from the options below that correctly represent the rational function. So I've got a graph and I've got a variety of equations with small differences between them. Personally, the first thing that I'm going to do is I'm going to locate zeros and vertical asymptotes because those can be clearly seen in the structure of the function as basic factored forms. So we know for a rational function, it has zeros are located in the top of the fraction, vertical asymptotes are located in the bottom. So right now I see a 0 at x equals -2, a 0 at x equals 0, and a 0 at x equals 1, as well as a vertical asymptote at, this is halfway between 0 and -2, so at -1. So zeros are anything that if you plug in that value to the factored form of the numerator, it will take the entire term to 0. So for instance, what could you plug 1 into and that term goes away? Well, you could plug 1 into x minus 1, right? If 1 goes into this term, it's going to be 1 minus 1, which is 0. Since it's going to be a product, 0 times anything is 0. That's what takes the whole function value to 0. Similarly, x minus 0 is what would be for the second term, except that's just going to simplify to x because 0, anything minus 0 is just itself. And then think about what would be for this next term. Okay, what happens? What do you plug -2 in and it goes away to 0? Well, that would be x plus 2. Another way to think about it, it's always minus the 0 location, so x minus -2 becomes x plus 2. Now, this is just the basic format. In each case, there's going to be an exponent, and it's going to be either odd or even based on the behavior of the function. That's the idea of multiplicity. Do you see here that for -2, it kind of bounces? It goes down and then bounces back up at the 0. Whereas at the 0 of 0 and 1, do you see it kind of passes through? So whenever we have a pass-through behavior, this is just kind of a colloquial term, that's when you have odd multiplicity. And whenever your 0 bounces, that's when you have even multiplicity. So I'm going to have an even exponent here, odd here, and odd here. Now, without more work, I can't figure out what the exponents actually are, but that's not necessary. All we need to know is even and odd, and that will help us narrow down our choices. Now, similarly for the vertical asymptotes are factored forms that when you plug in that value, it makes the denominator go to 0, which makes the function not have a value at that point. That's why we have our vertical asymptote. So our vertical asymptote is at x equals -1, so that would be x plus 1. Now, to know the multiplicity of the vertical asymptote, do you see on the left side and the right side, they are both going up? They're in agreement. That's when you have even multiplicity when they're in agreement together. It would be odd multiplicity if about the vertical asymptote, one was going up, one was going down, or one was going down, one was going up. But when they're in agreement, either both up or both down, that is an even multiplicity. Now that I've sketched out this basic idea, I'm going to look at the answer choices. And we know, again, x minus 0 is just x, so that might make it easier for me to think about it. So my bottom one should be to an even number, so I'm going to look there. That makes C and D out because they're all to an odd number. And now what's the difference between A and B? Well, here in B, this is an odd because no exponent written is an implied 1, which is odd. No exponent written is implied 1, which is odd. No exponent 1 is implied 1, which is odd. But we found it needs to be even on the x plus 2 term. That's why A would be our answer choice. So here I've got a nice factored form of a rational function, and it asks me for the x-intercept. X-intercept is a different word for zeros, keep that in mind. And it is saying what x value makes the y value equal to 0. And zeros only come about from the numerator. So looking at this factored term, if I plug in an x equals 0 to the first term, that's 0 squared, 0 times anything is 0, that would make the whole term go to 0. And if I plugged in an x equals -4 here, -4 plus 4 is 0, 0 times anything is 0, that would go away. That makes me think that these both are zeros. However, you have to watch out for holes. If you've got a repeated term in the top and bottom, that's actually a hole, which we talked about in more detail in our lecture video, and it's not an x-intercept. And do y'all see that we've got the x plus 4 term and the x plus 4 term here? That means that this is telling us our hole. So the only x-intercept is at x equals 0, and the value of the hole is what makes this equal to 0. Well, an x minus negative 4 would make that equal to 0. Now it says find the vertical asymptotes as well for this expression. And the vertical asymptotes are what make the denominator 0 that are not holes. So the only terms in the denominator that are not holes are here and here. So x minus 2, what would make that 0? Well, x equals to 2. X minus 1 plus 1, what would make that equal to 0? X minus 1. And we were asked to write this from least to greatest, so negative 1 goes first, and then 2. Now looking at this, I've got an expression where I'm asked, for this rational function, where is the horizontal asymptote? And here I just put this quick reminder for us. Whenever you're dealing with a rational function, the horizontal asymptote is all based on is the numerator or the denominator higher powered. If so n is the top, if top is smaller than bottom overall exponent, then the horizontal asymptote is y equals 0. If they're the same, then the horizontal asymptote is whatever the leading coefficient is of the top over the bottom. And then if the top is bigger than the bottom exponent, then there's no horizontal asymptote. So let's look at this one. I've got a x, anytime you don't see an exponent, remember that's an implied 1. And then to find the overall power, we don't have to factor this whole out. We just have to factor the highest terms from top and bottom. This would become an x cubed plus other things. This times this, all the highest terms together at the bottom, would become an x cubed plus other things. The nice thing about the horizontal asymptote check is we just care about the biggest term on the top and the bottom. And would y'all agree in this case we're in where they have the same top and bottom term? So that means that the horizontal asymptote is whatever the leading coefficient is on both. But since they were all solely x's, I don't have any coefficients here. There's an implied 1 here. So horizontal asymptote is at 1 over 1, which is 1. So next up it says consider this function square root of x and 2x. Are they inverses of each other? Remember, if you want to check that two things are inverses, you just do f of g of x and g of f of x. Make sure to do both. It's not enough to do just one. And then c, does it equal x? Because if it does in both cases, they're inverses. If it doesn't, they're not inverses. And if it fails either one, it fails overall, so you don't have to check more. So f of g of x, let's see. The g of x, let's put it inside the square root of x, so we get square root of 2x. Well, I can just see that's not going to be x. So they are not inverses. So in this function, we're given the domain, negative 3, 120, range 0, 1,000. And keep in mind, we are allowed to equal negative 3 because of this nice closed bracket. And we're asked to find the domain of the inverse. Well, remember this helpful graphic. The domain of the original is the range of the inverse. And the range of the original is the domain of the inverse. So if they're asking me for the domain of the inverse, that's the range of the original. So that would be this one. So keep in mind that relationship. Domain of the original is the range of the inverse. Range of the original is the domain of the inverse. They flip-flop. Now these will be our final questions, and it has to do with direct and inverse proportionality. Remember, if it says something varies directly, you're dealing with this relationship. And if something varies inversely, you're dealing with this relationship. So quantity y varies directly with x. I would personally just immediately write out y equals k times x. That's how you get started. And now they give us some things to fill in the blanks and find the answer. If y equals 15 when x equals 3,
find y when x equals 2. Well, right away I can see if I plug in the y and x that are paired, I get a single term by itself, which means I can solve this and say k better be 5. Right? That's the only way 3 times something is 15. So my proportional relationship is 5x. So when x is 2, we see y equals 5 times 2, which is 10. That's our answer. Now, y varies. Okay, I didn't mean to copy the exact same thing here. Let me change it. Y varies inversely with x when y is 4, when x is 1, when x is 4. Because I copied it, if y'all would change it, if you need to, pause the video, reattempt it on your own, and then unpause and we'll go over the solution. So since our changed one says inversely, it's y is k times 1 over x, okay? Plug in the values. Y is 4, k is there, we're trying to find it. 1 over 1. Well, that tells me k is 4. So y equals 4 times 1 over x. Well, we want to know when x is 4, so that's y equals 4 times 1 over 4. So y here would be 1. So keep in mind the goal of this was kind of extra problems for you to test your understanding to identify areas of future study. None of these problems are gone into the amount of depth that they are in our lecture video, because this is really kind of a way for you to assess where do I need to focus my attention. So hopefully you tried them all and then checked your work so you know where should I focus. Once you have that information, go back in our lecture notes and our lecture videos and try more problems. I've also linked some additional practice problems that you can find in our week 1 Canvas page. And you're also welcome to reach out to me. If you're missing any questions, send me a picture of your work and I'll be happy to give you feedback. I wish you the best as you prepare for this exam, and please let me know if you have any questions.